Okay. My name is Bel Yapka. This is Project 2 for Game Artificial Intelligence. This week I'll be going over 4 different types of AI pathfinding movements. This week was not without its troubles or its glitches, so what I have here seems to show as best as I can, but there's definitely a couple of things missing, such as the betting. Did not have time to set that up, but it looks like I got all the pathfinding, which I see as probably the most important. Now, going over everything here. Alright, that's weird. Okay, I'm going to go over everything slowly, with starting with each racer. I think it's the best and easiest way to set everything up and show. But now, of course, the first one here is A-star racer. It is just a sphere over here. It has one algorithm on it for my A-star algorithm, and of course I will go over that. Now what I want to get rid of is these black squares here. I want to show how these work in a minute. But first I want to show how this works. Now here's my A-star agent. When I hit play, nothing's happening right now. However, if I click over here, he will move. He will move anywhere I click to, actually. Most important thing to note is, as of right now, it cannot go through walls. I click over here. It does not see the mouse. It cannot come through here. However, if I have a empty game object with a cube on it, just so you can see what's going on here. It probably would have been easier if I just did the cube, but this works as well. Turning this on, as you can see, this pops up now. Before, I clicked on here and it did not work. However, I click on it now, and it still does not work. Okay. Let's turn on the rest. Maybe that might be the problem. Alright, that was the problem. I did not have anywhere else to go. As you can see now, when I click on here, it now, even though it can't see my mouse, it still goes to it because of these squares here. That all they are is just an empty object. It would have been easier if I just made it a cube without an empty object with a child underneath it as a cube. However, most important thing is it is tagged A-star point, A-star point, and also A-star point. Without this, it would have no idea where to go. And of course, this is set in code, and I will go over that in a second. But just a quick recap of what's going on here. These points, as you take them away, the AI agent cannot see them anymore, cannot go through walls, has no clue what's going on. However, if you do it over here, you can do that, and it will bring you back around. Now, turning it back on, of course, now, and here we go. And of course, as you can go from here, it will go towards the points, which are essentially nodes. They're made right on the screen. The code tells where to go on it, and it will follow. Now, getting to the code, this code is probably the most complicated, so I kind of wanted to get it out of the way. There's actually a algorithm here, which is the A-star algorithm. Let's put this over here. Now, this is a good amount of code. As you can see, it's definitely the most complicated thing we've been doing this week. But pretty much what I did is, of course, I made a class called A algorithm. I made an enum with 2 choices, stop or go. And of course, here are the variables: speed multiplier, first time check, time elapsed. Checking to see if it's on the node or not. This is the new vector that's made every time the mouse is clicked. And here is a node index for the use. List made with a list of paths that can be made into a vector. And we have two references to two other scripts that I will go over as well. In the awake, we open up a game object called scripts, and we instantly look for the camera. The reason why is because there is another script on camera that's pretty important. I'll go over that in a minute. Of course, and we got to pull a type of a node manager every time it wakes up. So in the update, we start moving, of course, with time, and we check to see how much time has elapsed, and compare that to how much the first time was. If it's more, we switch to stop, which is right here. And then if it's not, it'll switch to go. Now it checks again how much time has elapsed, and at that time it sets the target. If the path is not there, the node will go to onNode equals false, and if the node index is less than the path count, then the current node is changed to node index here. Now moving along, this is what makes everything happen as far as the movement goes. We have movement in the X direction, movement in the Y direction, and it's switching states, and sets the target here, and we'll switch to see which order is next and what to move, and this is to switch to state. Now the actual heart of this is actually, no, that's not it. The actual heart is Node Manager. Now, Node Manager is pretty much the graph that is taken, that the algorithm takes care of. There are, this one is pretty lengthy as well, but pretty much what you're looking at is a few variables, vector, character, float, and node, just to get to the previous node, node cost, and the state of the node, and the node position, of course. Making a list of connected nodes, making a list of possible previous nodes. Here is a few get and set methods. Of course, we have to get the state, get the position, get the connected nodes, get the previous nodes, get the cost, get the possible previous nodes, and then, of course, we have to add them when we need to, add connected nodes to the list, add possible previous nodes to the list, and then here are our set methods, where we're going to set the previous node to its supposed place, set the state, set the cost. Of course, cost is the amount of weight from one node to another. Now, here's the actual the actual diagram of, or the actual algorithm of the movement, and the checking to see if the goal is in view, of course. If it is, then the raycast is sent here. Raycast is sent out, and from there it determines where to go through the vector, with the vector and the path here. Adding the path to the start position and target position, and of course returning the path. This all gets done if the goal is in view and there's no obstacles in the way. Now, of course, the obstacles are taken care of down here, but we have this is what I was talking about before. This is very important. This is the reason why the other points work. It's because it is finding the objects with this tag of A star point, and anything with that, it will use that as a node or a waypoint, or however you want to see it as. Of course, there's another list. Once you make a new list, and for each node in the node array, it is processed here with the movement and changing the nodes if it needs to be updated. The last node is saved here, and it will become the new node to go into the target position. It loops through those nodes in the node array, goes through each one, and then here is the next raycast as it goes through, and it goes through each node with the position and the distance. And of course, it adds the connected node here. Same thing with this one. This is if the target position is less than, actually the raycast is here, and of course we added the connected node here. We have another loop here that runs through the nodes from the start position, goes through all of them, And then it says if we have a complete search or the goal has been reached, set the false as a default. And while the search is not complete, you will loop through until the goal is found. As I said, this is pretty complicated here, but of course, it makes a new list here for the found connections, goes through that list, and processes them accordingly. If they, and then it goes, and of course, there's another for each here where it goes through all the possible nodes, and it will process them accordingly, adding possible nodes to the list to be checked. And of course, we got we're going to change the state, whether it's going to stop or go. Here, we got the last node is connected here, and for each one as it goes through. And then we have another for each loop. This one here is searches for the lowest cost of the previous node. Once it finds that, it brings it into these previous nodes, and it will loop through there as well and go through each one and process them accordingly. Here is if the goal is reached. Once the goal is reached, it will trace back to find the shortest route. And of course, this is where all that is processed. The list, of course, is updated here, and it will find the shortest path from here. And at the end, it will reverse it to know how to get back to where it started, and it will add it to the path here. And of course, once that's all figured out, once the algorithm does all it needs to do as far as finding the proper path through the nodes, it will return the proper path, or it will return null if it can't find the proper path. This is definitely the most complicated. It's actually kind of hard to explain 100%, but I mean that's the gist of that. Now there is one more that ties all this together, which is actually called camera control. What it does is it pulls in a reference to the A-star algorithm. Starts off, as long as it has a racer, it will pull that algorithm and use that. If it does not, of course, it will not do anything. But once it goes through update, it looks for a left click. If you click it, it will change states, and of course, wherever it is on the screen, input mouse position on the screen, it will go to that. And of course, first it'll check for raycast. Make sure that you are clicking on the floor. If you are not clicking on the floor, then of course it will not work. And then it goes through here. Now, this is another thing I did forget to mention here. The floor is just like A-star point. It has to be in here. Got to go to ground, and it has to be called floor. If this is not called floor, I can click on this ground and nothing will happen. Which is also pretty. It also shows too that if you click on anything besides the floor, nothing will happen. You have to click on the floor for anything to happen because it's set here. So that's just something I forgot to go over. But as far as the rest goes, camera does have camera has the node manager and the camera control script, and you must drop your racer in there, which of course is my A-star racer, to make all this work. That is pretty much the gist of how the A-star works. And of course, we have the quick recap on that. We got the points here. If they're not there, it will not know how to go around. But if you click on the other side, it will find the path to get to where it needs to go, which is pretty interesting. There, I would say the A-star is definitely the most complicated, but it is the most useful as far as what it can and can't do. And of course, we'll see that as I go along. Let's turn off this racer. And nav mesh racer. Of course, I'm not going to spend a lot of time on this. I did my entire project on it last week, so this is just the same thing as what the other one. I have enemy behavior that does the movement. I threw the nav mesh agent on there, which of course is very important. And you hit play on this, and of course, it does its thing. It'll rotate towards you. It'll do its thing. This is obviously the easiest one. It's all built into Unity. It takes literally 10 minutes to implement, and it's pretty accurate. Of course, though, it does have its quirks. Of course, it can only go in this area. It cannot go off this area. Now, say I take my guy here and put him over here. Of course, he will continue. He will go after him. And now you see, and the interesting thing here is this can be kind of considered as a node area, all these triangles here. So this is actually interesting because you can compare it to the A-star algorithm and even the Dykstra algorithm when we get to that. But when these can be considered as nodes, just think of like in the center there is a node, and this is the area that it controls, and it navigates through those areas via the pieces. So let's turn that off there. Like I said, I'm not going to spend too much time on this. This is very simple. I'll run over it just real quick. Look at just to make sure this virtually hasn't changed from the last project I did. It was very, very similar. The only thing I did change was finish line. That is the name of the goal now. And of course, same thing with the tags. One of the biggest things that I've noticed that I forget a lot is tagging anything, finishing the tag, and you wonder why it doesn't work, but it's not just a simple thing you did, which is where was that? That was finish line. Yes, here's my goal. As you can see, finish line is this. And of course, it was added here. So now moving along, we got the next racer, and this is the obstacle avoidance racer. Now this one I did have a little bit of trouble with. It does its job. However, it is very stupid looking. It's not smart at all. It runs in the walls and takes a sweet time to turn, and goes roundabout ways to even find the player in the first place. I worked on it for a long time. I don't really know what I'm doing wrong, but of course I'm going to go over everything here, and maybe I can get some help on that. But anyway, first let's actually turn on obstacle racer. That would help. Click there. All right, and now you hit play. And turn gizmos on so we can see what's going on here. So as you can see, this is my raycast that I made. He is going after the player, but not very intelligently. He's running into the walls. He sees it. It looks like it's trying to go around. It's going to probably leave the whole game board here. Now, the interesting thing on this, I'm going to go to the scene. It didn't forget its task. It is coming around, but it will not go around there, and it does run into walls. Now, I did notice it's also rotating. I tried to make it stop doing that several times, but I just couldn't figure out how. But I'm going to now go over the actual scripts that I have. That I would assume these were my problems lie, but really couldn't tell you exactly what I was doing wrong. But now the scripts on here, you do have an obstacle avoidance script. Clicking on this, we'll go over everything I have here. This is not half as complicated as the other stuff. I even added those lines for debugging to try to fix this, but I don't know what's going on. But anyway, obstacle avoidance, there's a few variables here: range, speed, whether or not there's anything in your way. The game object is the target, of course, the speed of the rotation, and of course you need the raycast for that to make it see what's going on, or attempt to. Now, in the start, I just set these so they're just set at a certain speed and range, rotation speed, so they won't be changed. Now, if the character sees an obstacle in its goal, in between it and the goal, it means, of course, there's something in its way. It will look at the relative position to the target, and it will subtract that position. It will rotate accordingly, and it will, of course, it will interpopulate with the slope here to keep everything kind of moving smooth. Now, when the obstacles are not present, it will go after the target, and forward times time times speed. It'll transform the left and right ray of the raycast, and then here is where all the obstacle avoidance is supposed to happen. Goes through the raycast, it sets up the left ray position, and so then it sets up, of course, it sets it up going forward, and it goes out the range that I've set, which is 80. Now, underneath here, this is, or if the right ray position touches anything, and it's within range, then it will continue here with the, it'll check for, here's another tag that I set up. It will check for obstacles. Anything that's considered an obstacle should be avoided by this. Now, as you can see, I have all my walls, exterior, interior, everything all says obstacles right here. So I know I have that set up right, but still having a little bit of trouble the way he's acting, even though he does seem to be responding to everything. But anyway, back to the code. We're going to set that there is nothing in the way. It is true that there is nothing in the way. It's just a little backwards. I probably should have set that up different, but it works like that. But transforms out, rotate. Okay, we're going to rotate towards away from the obstacle, either down at a certain rotation speed. Now, this is the same thing over here. We're going to check to see for any more obstacles, and if there are no any more obstacles, then we're going to change it to false, and we're going to, of course, continue on back here towards the player, and always looking for things in the way. Now, what this is here is the rays that I drew. I try to use to debug my situation. They do work. They do go on the screen, and you can see them. Now, you would think that when these things touch the walls, that it would respond a little faster, but for some reason it does not. Now, if there's any, I'm just going to quickly leave this here. Just anybody who wants to look at this, see if there's anything I'm doing wrong, if there's anything at all that I could use to make this work a little better and not be as crazy there. But let me just double check. I didn't miss anything for this one. Obstacle avoidance. No, I mean, of course, I have a rigid body on here. I mean, this. I did try to change this around to see if that would help at all for the rotating. I mean, as you can see, I mean, it tries to do its job. It sees there's something going on. It sees there's a problem, but I mean, it doesn't continue running into it. But it just doesn't want to go directly towards here when it could have easily just made a right-hand turn and came up and made a left. So anyway, if anybody has any ideas on that, that'd be great. But moving along, going to the Dykstra Ray Tracer. Let's turn this off to get this out of the way. And turn this on. This one's a little bit more complicated than that. It's a lot more complicated than that mesh, a little bit more complicated than obstacle avoidance, but not as complicated as A-Star, just because of the fact that it kind of is A-Star, just dumbed down a bit. A-Star uses the heuristic, and Dykstra just kind of checks everything, which is not really the best way to do things. It just takes too much time to check every single node to see your best path. When the A-Star Racer can use the heuristic to figure out a much smarter path. Well, I should say less steps, not as many steps. So now, as far as the Dykstra Racer, we do have two scripts on here. This one here, there's actually nodes that I created here, kind of like the A-Star. A little different though, and I will go over what's different about them. But of course, these are the points. There's three of them. They work just like the other one as far as the tag goes. It must be called point because it is considered point in the script. And once we get to the point, I will go over this part as well. But starting with this, I'm going to hit play, and you're going to see this guy here. He's kind of moving a little bit, kind of going towards there, and then he's kind of moving around. Now, he sees me on the other side of this wall for some reason, but not really 100% sure. Oh, he sees me. It's almost like he's realizing, hey, this is not the greatest path. Yep, okay. And slowly but surely, okay, it looks like he might have lost me here. Now, this actually has a lot to do with the fact that there's a wall here. He's only going to go through these paths. If he doesn't see me, he's going to continue back, and he should end up back at this path. So what we're going to try to do is we're going to try to make it so he can see me and see how that works. Go from there and go there. And hit play. Let's see what's happening here. So, oh, and now he does see me actually. He is taking a much more roundabout path to get to me. And let's stop that. Let's start this over again. As you can see, these are the little troubles that I did have. Everything kind of works, but it's lazy, it's slow, it's not as intelligent as I wanted it to be. I'm sure there's definitely things that I can do to make this better. I'm just not 100% sure what at this time. But continuing on, we just want to. There we go. Okay. And he will stop there. Okay. So, I mean, he is coming towards me. It's obviously not right. He's still, he kind of oscillates around me a little bit, but now the whole point of, let's see, first thing I'll do is I'll just go over the scripts. Dykstra Racer, we have two. We have a Dykstra AI script. We have a current node script, and then we'll go over the points after that, and there's also a script on there that makes this all kind of work. But here's the Dykstra AI. Now, this controls the movement of the AI agent. This pretty much tells the AI agent to go towards the player, and if it can't see the player, it will travel to the next path, the next node in the path. This pretty much says go towards the node of the player. Everything here is the vectors for position and direction, and what they equal and how to move them. This here, I did set it so that the Y direction cannot move. I did try to do that with the obstacle avoidance, but I was unsuccessful in doing that to try to keep it from, going around too much. But the vector 3 here, normalized goal direction, just normalizes the direction so the player doesn't jump around too much. And then here it rotates towards the player as well. Now, actually, I should say it rotates toward the node that the player is in. Now, if it can't see the player, doesn't know what node it's in, it travels to the next node in the path to try to get to that. And this is very similar to this, except for, again, here, this is where it says find the point. This is going to always go towards what point is. This is the same thing here. This is finish line, which is your goal. Now, if I wanted to change this so that my player went straight, or my AI guy goes straight to my finish line, I can change that to finish line, but I didn't really want him to. I wanted him to go through the nodes first, but just to see how they work. And this is, like I said, this is very similar to up here, just trying to get the guy moving and going towards the next node, whether it is the node with the goal in it, or a node that does not have a goal in it, but it's the next step to get there. And that is the main movement on there. And now we can go back to Dykstra. We have the current node, which this one is pretty simple too. This just sets the current node so that it knows where it's supposed to be. Now, all it's really doing is looking for the shortest path here. Again, it's looking for a point, which is the point is the tag right here. Point. In that point is it shows if the distance is less than the shortest path, then we change the shortest path to the distance, and the current node becomes the next object, next game object. And in update, we call set current node to always set that node. Now, if you go back to Dykstra Racer, those are pretty much the two scripts that I have here. I did throw a rigid body on all my racers, just so they don't bounce around too much, hitting each other and things like that. Now, if you go to point, which are my points that they're supposed to travel to, they're actually these gizmos here. The gizmos I made myself in script, which isn't going to be in this node. And pretty much what it does is it tells the neighbors of these nodes, and it knows where it can go and where it can't go from there. Of course, there's only 3 here. If there were several, it will be able to choose from different ones, and this array can take any amount you need. You can make, I'm sure you can make 100 of them if you need to. But that's that right there. So let's go to the node script. Let's take a peek at that. Now this one is it's pretty much everything with the gizmos and the colors and how to make them. And then again, I did use this down here for node. Find the game object with the node. Actually, let's see here. Yeah, this uses Dykstra's algorithm, as you can see here, as it goes around. If the goal is present, the goal is not the goal to target. It's actually the goal from one node to a next node. I don't want to get that confused. But it does use the Dykstra algorithm here to pull up that one. Now, I did seem to forget to even mention the algorithm here, and that was because it doesn't go on my game object. It's just a static, not static, but it is a standalone script that I can pull information from, and of course this does all of the Dykstra the Dykstra ideas. And like I said before, the difference between Dykstra and A* is the lack of heuristic. This just says to go to the shortest node, pretty much. It wants to see. It looks at almost all the nodes to do that, if not all the nodes. So what I did was I created a dictionary, 2 of them actually. They're a little, just a touch different than lists. They seem to be a little bit more functional, in my opinion. But use the dictionaries, and you create new dictionaries that will hold all the game objects, which of course are the nodes. Here's the list here. This is going to be the list of the nodes. Now you're going to go through each node here. You're going to get rid of the previous node. You're going to add all nodes together at the same time, so that it knows where it's supposed to go. Now, while there's more than 0 nodes to be checked, which of course means before it looks through every single node, it will pull up the game objects to the shortest path. It'll set to null. It'll loop through all the game objects, which are the nodes, of course, again, and it will once it finds the shortest path, it will remove remove them from the list. This is checking if the target is reached using a stack. Of course, a stack is first in, last out. First in, first out. No, first in, last out. That's right. It's like a stack of papers, of course. So I use this for all of the nodes. And then when all the nodes have been checked, stop checking them. Of course, that's what break means. And then you can loop through all the neighboring nodes. You can set the alternate node and then choose the alternate node. And then, of course, return null there. Now, this is still complicated. It is definitely a little bit hard to completely explain, but of course, it's not as complicated as the A*. Pretty much, basically, it is just a bunch of nodes that are out. The Dykstra algorithm checks all of the nodes and then chooses the path to go from there. Let's just go back here, make sure I didn't miss anything. Now, this goal was just for debugging purposes. There's none. That's just the goal, is the next node. So what I'm going to do, I'm just going to turn all of them on real quick. Turn all my racers on. I'm going to move my guy back over here. So he's a little, let's put him up here. put them next to this node here. And then we hit play. So now, of course, betting on these would be almost silly just because the slowness, they work well. You know, as you can see, it did make a beeline for me, and then it kind of hit the wall. And now it seems like it knows where it's going, but now it's kind of spinning around. But as you can see, these two made it right to the player. This one, of course, is the A star, and that will make it to the player, of course, as well. If you want to make it to the player and without having to click on it several times, turn these on, bring him back over here, as you can see, and then bring him back over here. Now, this is actually a nice little eye-opener. I mean, of course, I'm sure I didn't make the algorithm, or I didn't set everything up 100%, as you can see, but still, even after that, the nav mesh is the first one to get there. It's definitely the easiest to use. Of course, it's not as functional, and I'm sure if I did this 100% correctly, it might be just as functional as the other stuff. But the nav mesh is still the easiest thing to use, as you can see. But you know, it's a near miss with the obstacle avoidance guy. I mean, he almost made it to me. This one here is just moving really slow. It's only going to go for here. I'm sure I can speed him up. If I added another node here, that would probably help. But like I said, it's just for just to show purposes, just to see how things work. And of course, we have this one here. And that's pretty much the gist of it. I just want to make sure I didn't miss anything. Oh yeah, one thing I did want to do, of course, I didn't set it up so that there was a race so that you could see the changing obstacle avoidance, but I can still show the change in obstacle avoidance. What I'll do is I'll do each one alone, and that's not what I want to do. I'm going to do each one alone, and I'm going to show how each racer will change. And we got this one here. Let's go to scenes, and we're going to grab my guy, and we're going to move him around. And kind of pass that right there. Oh, and as I go from node to node, I'm in this node here. I'll move to this node. Well, yeah, unfortunately, he's not working as well as I wanted him to. But going to the next one, it's going to be the obstacle avoidance. Play there. Go to the scene. And maybe we should turn the guy on first. And there you go. All right, and as you can see, he is avoiding some obstacles and following me around. And you know, as I move, I mean, he is coming after me. He is moving around the walls. I mean, not making much of a beeline for me, but he is moving. He is following me, and he's adjusting you know, as he goes off the map. But he is still coming after me, avoiding the obstacles as he goes along. So that one kind of works. That's good. Now, nav mesh, of course, this is, we know this one works well. This one is, you know, I can move the guy where I want. He'll come after me. Of course, just like I said in the last one, he will not leave this thing. He will not leave the area because there's no nav mesh there. So that's one thing to be wary of, you know, but he will follow. He will follow all around and come after me. So, all right. And the last one will be the A-Star Racer. This one, the way I set it up, I wanted to show how the waypoints work. So this one is a little different. It's not going to work like that, but and that's pretty much it. Oh, I did put the current node on here as well. I put the current node script just so it would know Oops. All right, and again, definitely had a little bit of hard time with this week. This stuff is, sure everyone would agree, it's just pretty complicated, and I think I'm going to need a lot more than a week to get this right. But if anybody has any pointers, anything like that, anything that they saw that I was doing wrong, obviously wrong, if they could let me know, that'd be awesome. Be very happy with that. And these are actually some nodes that I made prior. As you can see how many you can put on the screen, I put on many, many of them just to show it's like a spider web. Now, if I change these all to point, which actually I'm going to do that right now. I'm going to do that real quick. And go here and change all of these to point. And go from there. And then I'm going to just hit play one more time and just any change all. Right. And the Dykstra Racer kind of stopped moving here, unless I did something wrong. Anyway, probably had something to do with these points that I did. Let's change them back and see if that does anything. Go back to where it was. All right, and then hit play one more time. There we go. All right. But as you can see, this was actually a different setup. But all of these here, you can go to any. These are actually a different setup I had before. But as you can see there, you can move these all around, all over the place. They can go wherever you want them to go, and they're pretty useful. As you can see, moves like that, moves like that, and the pads stay here, but they are like that. But that's pretty much it for this week. And like I said, I had a little bit of trouble, as you can see, how things went. But these are pretty much how I wrote 1, 2, 3 algorithms to get a star algorithm to work. And then I wrote 1, 2, 3 to get Dykstra to work. And then to get the obstacle avoidance, there was actually 4 for the Dykstra. Obstacle avoidance was simple. That was just one script, and then the camera control helped out with the A algorithm as well. So, as you can see, is 1, 2, 3, 4, 5, 6, 7, 8, 9 scripts, power and everything. I'm sure tweaking here and there will make it better, but it all came together. So, thank you very much.